All right, so on number 2, we had a glitch in the system. So number 1 is up here. Number 2, we circle moles, underline and label molarity, liters. So our formula is molarity equals moles divided by liters. So I'm looking for moles. I circle it. I put it by itself. Moles equals anything my unknown would multiply with becomes a denominator because it's understood that this is 1. So it's molarity times liters. Draw our little line, and molarity is 4.00 molar times 0.450 liters. And what do we come up with? 1.80 moles. Okay. What is the molarity of a solution of 56.2 grams of sodium carbonate or dissolved in 500 milliliters of water? There's our molarity. Grams, we can use grams to get to moles during a via a mole problem. And this is liters. So molarity equals moles divided by liters. Okay, first thing we have to do is convert 56.2 grams of sodium carbonate. The words on the top or the words on the bottom. What's the molar mass of sodium carbonate? 105.99. Do the math, and how many moles do I get? 0.96. That can't be right because this is because this is 50 and this would be 100, so it'd be right at 100. I mean right at 50%. So what'd you say? 0.5. 56.2 divided by 105.99. So it's going to be 0.53 moles. And then we're just going to divide that through by our liters, 0.500 liters. And so the answer is 0.53 divided by 0.5, 1.06 molar. Questions on that one? Okay, so how many grams of magnesium sulfate are needed to make a 6 molar solution that's 600 milliliters in volume? So we can go from moles to grams here, and this would be my molarity, and this would be my volume. So our formula is molarity equals moles divided by liters. I'm looking for moles in this case, so moles equals molarity times liter. So 6.0 times 0.600 liters, and we get 3.6 moles. Then the words on the top or the words on the bottom. 1 mole of magnesium sulfate is equal to how many grams? What's the molar mass? What was it? 120.47 grams of magnesium sulfate. Okay, multiply across the top times 3.6, and we get 433.69 grams. We're going to do it in scientific notation. Because of 2 sig figs, we'd have 4.3 times 10 to the second grams. Okay. All right, dilutions. Dilutions have more what than what? They have more solvent, because they're dissolved, than solute. Oh, I'm so sorry. That's not what that says. They have more solvent than the original compound. Okay, because there's more water or whatever in it. So this is our formula. M1, the initial molarity times the initial volume equals the final molarity times the final volume. And we need to be in liters. What is added to 200 milliliters? Oops, sorry, that's not liters. It's a volume. Of a 2.0 molar solution, there's an M1, of calcium chloride to increase the volume of the solution to 400 milliliters. There's a V2. What is the new concentration? There's an M2. So our formula is M1V1 equals M2V2, an inverse relationship. Okay, so we're looking for M2. Divide 3 by V2, so M2 equals V2 on the bottom, M1, V1 on the top. So 2.0 molar times 0.200 liters divided by 0.400 liters. And we get what? We could make that a 1 and make that a 2. So what's 2 divided by 0.2? Is that what you got? No. This would be 2 times 0.1, I'm sorry, would give me 0.2 divided by 0.2 would give me 1 molar solution. Okay, so it'd be a 1 molar solution. Questions on that one? You don't have to divide through, I just did it for ease. All right, to what volume must 1 liter of a 6 molar solution of hydrochloric acid be diluted in order to prepare a 0.2 molar solution? So this is actually going to be my V2. This is my V1, my M1, and my M2. So M1 V1 equals M2 V2. We're looking for V2. Circle it, put it by itself. Anything the unknown will multiply with becomes a denominator. Okay, M1 is 6.0 molar times 1 liter divided by 0.2 molar. And what did we come up with? 30. It will be 30 liters, right? Final answer.